One of the most challenging topics in the first year of our physics degree is a mind-boggling statistical concept called covariance. Although it's linked to many equations and data analysis, it's fairly useful in everyday life. The main concept of covariance is that it helps us understand how two variables are linked to each other, and more so how two random variables are related in a dataset. There are three types of covariance: positive, negative, and zero. Positive covariance means that the two variables move in the same direction. Negative means that they move in opposite directions, and zero means that there's no correlation at all. Today, with my friends and colleagues, Ayush, Mahir, and Leonard, we're going to teach you covariance.
You're now a rich physicist, and now it's time to start investing in stocks. You know you should never put your eggs in the same basket, so you invest in a variety of stocks like Honda, milk, telecoms, whatever you want to. But one day, you find that your milk and your Honda stocks have both gone down at the same time, and you're scared you're going to lose all your money. You're confused, you never did economics, so you don't know why it's happening. You don't know what to turn to. Of course, as a physicist, we're all about the numbers, so the best thing we can turn to is covariance, which Mahir will now explain.
This is the covariance formula. To explain it, I'll start with the numerator and specifically focus on one bracket. What does xi minus x bar mean? Well, it's each element from x subtract the mean of all the numbers in x. We could call this deviation from the mean. And for example, if x contains 1, 2, and 3, the mean would be 2, and so the deviations would be -1, 0, and 1 respectively. You take these numbers, and you do the same for y, and you just multiply them. So the first deviation from the first deviation, etc., etc. And then sum that all together, and that would be your numerator. For the denominator, we have n minus 1, and the question really here is, why are we subtracting 1? And the reason here is because if x and y are samples of a larger data set, then you divide by n minus 1. If not, then you can divide by n. Examples of why x or y would be a sample is if, for example, a field of flowers and you just take a section of the field to represent the whole field, or if you take a survey of people to represent the whole city.
Now, after learning all that concept, now let's take a back look at the portfolio example. Suppose you are going to reduce the risk to the minimum so that you could invest better. You grab all the data from the daily return according to the closing price of each day. Now, as shown on this PPT here, you can see all the data sets. And now, recall all the original formula and input all the parameters in it, we get this one here. Simply by subtracting all the daily return by the average return. And multiply together, divided by n minus 1. Don't forget about n minus 1 because you are using a very small sample of it. Now pause the video and think about how to calculate this and what does it tell you about this.
We hope you paused the video.
Now here's the solution here. You can see that simplifying all that number here read down to a 0.0955, which is a positive number. Recall that we talked about it. The positive covariance tells you about the two data sets moving together into a same direction. And the minus covariance tells you that they move opposite direction. But simply by this, we cannot get enough information for that. You may wonder how good they move it together. So now here we introduce a new concept called correlation. The equation goes like this. You can check that simply by dividing covariance by the standard deviation of two data sets. And in this example, the correlation we get number is this. It's a positive number, so it's just like covariance tells you the two data sets, they move together in the same direction. Now the value itself varies from -1 to 1, and the sign is only dependent on the covariance, because sigma, standard deviation, could not be negative. So suppose that the correlation value is -1. It tells you that they move perfectly opposite directions. If it is 1, it tells you that they move perfectly in the same direction. So now check this example. The value tells you that it is close to 0, which means they move random directions instead of moving together. So you may not want to invest in this stock. Now hopefully, after we introduce all these concepts of covariance and application of it, and as well as correlation, you you can now have a better view of how to invest in a portfolio. And that ends our video. Thank you for watching.
We hope you paused the video.
With a smile, with a smile.
Okay.
With a smile. I don't think it's scared. I don't think it's
We hope you paused the video.
Can't believe you're just gonna end this. Stop. End this right now. Cease.